That's Zoom. Okay. That's Zoom. Get back to Zoom and fix these zeichnen. Ja, yes, verstanden. Ja. Großen beiden. Okay. Yeah. And we're gonna open this one, right? Go to YouTube. Okay. Yes. Oh. Yes, sir. And this one we're gonna open. Over it here. And YouTube, right? And just go to go live. Go to go live. These two. Oh, what's the problem? Go live and check this one. So this is the yes. This one. Hey. Hey. Your Safari. Hey. Hey. What? Yes. Yes. And anh Mel, no, it's not a SK, yes, sir. SK2, right? Let's go with that. the actor is in. Woohoo. Really? Okay. Okay. And go live. So it's on to right. What's the problem? Yes, our stream software. It's no, it's not made for key. What time is 28? Let's take this Zoom, right? Yes, yeah. Public education. Save. Okay. And yes, we're gonna set the one. Hey. Oh. Okay. Yes, sir. With that. Oh, poor right now. Go to big page. And this 5G. These steps. Go to the C lab. Right. C lab. What's the reason? Hamilton. And yeah. Okay. Yes. All right. Yes. Yes. Okay. Here's that one. All right. Let's look how we fly out. These. Oh, where is that? Here. Should have something. Shouting system person. Where though? Okay. Yes. Let's. 1709. Here's this right to alter that. Okay, and we're gonna stop these. Have youมาแล้วนะพัดมาแล้วเลยwait. I may. This one. Steam software. No, it's not made for key. Okay, just this one. And right. I hope it works well, right? So let's check here. Yes, please. Please. And here you didn't let it run. Okay, seems to be fine, right? I hope so. So stop this. Second that is then close the microphone here and open. This one. Wait. Why? Okay. This one. Yes. Okay. 1, 2, 3. Yes, this count in. We start first good morning. I need to check whether the words fine or not. Test 1, 2, 3. Yes. All right. Yes. I hope this one
works. Okay. Good morning, everybody. Sorry for being late. We will go ahead with the chapter 5, right? M60426 here. 60426 here. All right. Okay. Same file. And yes, we arrived at the problem, right? A problem that is related to มีใครจะเข้าที่เขาเรียกว่าอะไรที่ซูมไหมครับก็จะพยายามชำเลืองมองให้นะครับ we almost complete the whole thing here, right? Yes, but it's very complicated. Okay, because this is the last topic of our chapter, and I heard that we are going to have soon the midterm exam, right? And the exam is going to be held at the school, okay, physical way. And yes, I hope that you would be ready to. I would say that the homework on site. No. The midterm exam on site is going to be harder or more difficult than the one you usually see in the last semester. Okay, and that's more difficult, I would say. No. The one in the last in the previous semester is easier. Okay, it's only 7 problems, and you just write. Okay, you just write down the solution, right? So that's it. But in the midterm exam, which will be held at school, you would have 30 or 40 problems and a few more problems to write down. So it's written exam or something like that. So yeah, you would realize that it's a little bit more difficult, right? Yeah. Yes, let's talk about the usually yeah, one important thing is that you will be the only program of your school to have the midterm exam with calculator. Okay, you are allowed to bring your an electronic calculator with you. Okay, I will talk with the teacher at your school. Okay, so that you have no problem when you bring a calculator. Okay, which will be very, very different from other students. Okay, even in the same year as you. Okay, in Mathematics 6. Okay, you will be only M604 and M605 will be only 2 classes. Okay, that are allowed to have electronic calculator with you at hand. Okay, to solve the midterm exam. Okay, you are also able to not bring the calculator inside the midterm exam if you believe that you can use your brain to take some decimal results without any calculator. Okay, but I don't know what about the arcsine or something like that, or arctan or exponential or something like that. I don't know how you would be able to get the results. Okay, yeah, anyway, I would give you first the introduction about midterm exam that will be held at school on site. Okay, let's get into this story. yes, the sheriff, like it's like a police. He has shot. He tried to shoot this person, but the piston has missed this the body of this person, the bad guy, okay, who steals something from the people. So yeah, that's so he's not a good person. So yeah, we try to the policeman try to remove him, okay, from the society. Yeah, and the piston, the bullet actually has hit the container, the water tank of the town. And yes, you would be able to imagine that the piston is going to be broken, and there will be hole, right? And what you can see here is the hole, okay. And of course, because there is water inside the tank, okay, staying inside the tank, and it's going to flow out, and we're going to find what is the distance along the x-axis in the horizontal way. Okay, มีใครอยู่ที่ซูมใช้สิทธิ์ครับคือผมยาวแล้วผมขี้เกียจใส่หูฟังอะไรมันรำคาญครับไม่ได้มัดผมนะเวลาไม่พอโอเคyes ถ้าคนที่ซูมจะพูดอะไรก็เรียนเชิญนะครับผมพยายามใส่หูฟังคุณครับ alright okay yes the problem is that we will apply, all right, we're going to apply the Bentley equation, okay, the summation of three terms of pressure at any state, right, which will be equal to each other. All right, yes มีใครจะเข้าอยู่ครับใช้สิทธิ์พิมพ์มาแล้วนะ okay yeah, the one here, I didn't send you the link of the YouTube, right? There are three channels, right? This one too, right? Oh, I have to close this one actually, because it's going to consume the internet bandwidth. YouTube, and no, it's your channel. Okay, let me. Oh, I don't understand why this one. All right, and yeah, what is that? The line chat program. Tap right, and tap right, and yes, we're gonna have these right. Oh,ไม่คุ้นมือเลยครับคีย์บอร์ดทำไมครับ where's the line? Okay, line is here in M604, right? 604. Copy and Control V, right? The first link. Oh. Yes, we have to stop, and this is another link, right? Up to you. Okay, I stop too, right? And this one. มีประวินครับมีประวินคนเดียว okay yes sir okay yes the right the Bentley equation is what we're gonna use to solve these, right? And yes, we would go ahead with that. We want to determine the distance x, right? It means we would need to know somehow the velocity here, Vx, right? Okay. Yes, let's go ahead with that. At the first location, the pressure which is caused by the air here is PATM, right? And of course, in the second hole, okay, second location, it's also the same pressure, right? The pressure caused by the air. Let's say wherever, okay, if you leave if this scenario happens on top of the, I don't know, the high mountain in Nepal, it's going to be the same, okay, because the pressure difference between this location is minimal, okay, it's very, very tiny, so we don't need to pay attention so much attention to that, okay, because it's only 0.5 meter different, right? They say the water level is 0.5 meter above the hole. So yes, here you have the level 0.5 meter. Okay, this problem is a little bit complicated. Actually, the story here is complicated because there are 3 terms you have to worry about. All right, PATM, right? The first term, PATM. Okay, and the second one, of course, if you compare here, you have Y1, you don't have any height, right? It's measured with respect to the water level. There is no potential energy at all, right? So I don't know how we call it. How do we call it? I don't know how we call it in, right? Yeah, potential energy per unit volume. Okay, there is no potential energy per unit volume at the no potential energy per unit volume. Okay, there is no potential energy per unit volume. It is at the first location, which is this one here, this location. Okay, and V1, this is the first location, right? Vx, we don't know Vx, right? In I don't know how do they solve it. All right, there is no speed, okay, of the water at this location. Okay, so V1 is 0. All right, V1 is 0, and V2. Okay, let's talk about the second location here, the hole here, right? First, we have to look for the pressure, right? P2, the pressure of the air at this location. Okay, let's just take a look at this. The pressure of the air at this location will be the same. Okay, it's not, the height is not so significant. Okay, it's not meaningful, 0.5 meter only. So P2 is going to be the same value, PATM, right? And Y2, of course, sorry for it. คอยังไม่ค่อยดีนะครับ P2 is the height, okay, is the height of the second location, okay, it's the depth actually measured from the water level here. Oh, air เพิ่งทำงานครับเพิ่งเย็น okay, yes, Y2 is, what is that? Yeah, as you know, it's here, it's, what is that? It's 0.5 meter, right? It's 0.5 meters, so we're gonna write down here 0.5 meter, and the velocity here is Vx, which is what we don't know. Okay, V2 is Vx, and we need to find, right? Okay, you substitute these parameters, these values into the Bernoulli's equation. Bernoulli's equation says that the summation of three terms of pressure remain the same for any location, right? P1 plus 1 by 2, right? This 103, okay? Equation 103, rho gy, okay, the potential rho g y1 plus 1 by 2 and rho v1 square equals P2, okay, the pressure at the second location, and plus rho g y 2 and plus 1 by 2 rho v2 square. Okay, you know that we live this environment on Earth, right? The gravitational acceleration G will be the same for both scenarios, right? And we use the same kind of liquid, which is water. So the density low rho, right? The variable rho is going to be the same, which is 1,000 kilogram per cubic meter, right? Yeah, it's not difficult, right? So yeah. Next one is that we are going to substitute everything in here. You know that this P1 is PATM, right? Rho is rho g y2, right? But rho g times 0 is going to remain 0, right? And 1 by 2 and where's that? No, y1 is the height, okay? It's the y1 is 0.5 meter. No, it's not 0. y1 is 0.5 meter, and y2, okay, is the reference level is gonna be 0, right? 0 meter. Okay, and this one is we write down h, okay? H is the height, and 1 by 2 rho, and the initial speed of the water here, it has no flow at all, right? So it's going to be 0 square, right? 0 square, and what else? Okay, let me check the file here. Let me check the file here. Okay, all right. Yes. Equals, right? Equal P2, right? P2 is PATM, right? The pressure at that location, the pressure caused by the air. The pressure at this hole, okay, caused by the air will be the same, the atmospheric pressure, and rho plus rho g. Y2, the height here is 0 and plus 1 by 2 rho v2. V2 is the speed, right? It's the speed of the water going out, out of this hole. So it's gonna be Vx, which is what we would like to know, right? And you know that if you move PATM to be negative at this side, it's going to cancel. It's going to cancel another PATM, right? Both will disappear. And rho GH is right there. This one is 0, right? And you can have rho GH equals 1/2 rho Vx square, right? And of course, we use the same kind of liquid in this. We can cancel rho here. And of course, Vx will appear right now, will emerge right now as the square root of 2g and h, right? So let's substitute the numeric value to this one, right? 2 and 9.8, okay, and h is 0.5. And of course, you're gonna have square root of 9.8 only because 2 and 0.5. I'm gonna bring you number 1 only, right? So let's use the calculator. ผมขออนุญาตใช้คอมพิวเตอร์นะครับ Okay. The calculator here says October rate, square root of rate, square root of 9.8, right? That's Vx, right? Okay, it's gonna be 0, right? Oh, ทำไมไม่ขึ้น Okay. Huh? Oh yeah. V is the speed, right? It's square root 2gh. It's 3 point. Oh, มันเล็กๆแล้วกันนะเพื่อไม่ให้มันAll right, 3, yes, the same thing. Okay, here we get the approximation, which is 3.1305, and the unit of the speed is meter per second in standard way of the SI system, right? Yeah, we get that, and yeah, but our target here is that we want to find the distance, okay, away from the hole, right? If you project the hole onto the ground, and we need to find how far the water projectile motion gonna drop onto the floor or the ground on Earth right here. Of course, we would follow the same manner in last time, right? We need to find, because of course any projectile motion has both the motions in y-axis, in the x-axis and in the y-axis, right? And you know that Vx is going to be horizontal velocity here, right? It's horizontal velocity. Vx is actually u, okay, u for the motion along the x-axis, right? In yeah. But for the y or the vertical motion, uy, what is that? Uy is 0, right? Because there is no initial speed of the water in this direction, right? The whole caused by the bull light is assumed to be in parallel to the ground. Okay, so uv is 0. So how high? They say that from the information Okay, the first quantity has been complete, right? The first thing, the speed of the water leaving the hole, okay, is 3.13. That's the speed in the first question, right? We have delivered the answer already. We have found already the answer, right? Let's talk about the second question. If the hole is 3 meters above the ground, okay, so the hole here is 3 meters from the ground, right? So yeah, we know that we have to divide we have to separate the motion into two axes, right? Let's consider the vertical motion first, right? The motion along the y-axis. Okay, let's consider the vertical motion. Of course, we have here uy, right? That's the initial speed. It's 0 meters per second, right? But the water drop has also, the water drop is subjected to the acceleration, okay, on Earth, which is g, and it's 9.8 meter per second, right? It's 9 meter per second squared, okay, and yeah, the height here, h is 3 meter, okay, 3 meter. Okay, the height here is different from the height in this expression. Okay, the height here is, okay, let's say it's h hole. Okay, it's h hole. The height of the hole. Height of the hole. Oh no. We would rather not use. Okay, we will say h here is the height of the hole above the ground. Okay, h hole. And yeah, from the ground, right? And of course there will be final speed vy, but we don't know. We don't want to find it. The important thing is the time. Okay, the time consumed from here, from the hole to the ground, right? We need to find the time along the y-axis, right? And ty, what is that, right? And of course, you need to recall some basic formulas about the motion subject to acceleration, right? You need to recall or remind yourself. มีใครจะเข้าที่ซูมไหมครับแล้วผมไม่เห็นเดี๋ยวคุณจะว่าผมนะครับ Okay, we have to remind ourselves about the possible formula that are gonna be chosen to solve this problem, right? What is that? We have v equal u plus at, right? We have what is that? UAT, okay, and v square equal to u square plus 2as, right? And we have another one, which is what is that? S equal to ut plus 1 by 2 and at square, right? These are three. Actually, there are one more. There is one more, right? But these are three basics formula you can choose to solve this, right? And yeah, what is the variant? What is the correct formula for that? Of course, we know u, right? U, okay, the whole three equations involve u, okay. We have h, which is distance. Distance is going to be the second and the third, right? We want to find ty, right? So we have to deal with this. We have to choose this one, right? S equal UT is equal to UT plus 1 by 2 AT squared, right? What is S? S is H whole, right? H whole equal UT UY. UY is 0, right? UY is 0 and TY is unknown, right? And plus 1 by 2. A is the acceleration, okay? The gravitational acceleration G, right? And T is T squared of the axis Y, right? The Y axis. And of course, in order to find Ty, this term vanishes, right? This term disappear, right? It's going to be 0, right? So we move number 2 to this one. We move G to the left hand side and take the square root on both sides. So Ty, right, is going to be square root of 2h whole divided by G, right? And of course, it's going to be square root 2h whole. The height of the hole is 0.3 meter. Okay, we have nothing to change, right? It's the SI quantity. G is 9.8, right? 9.8. So you can put it into the calculator. In the calculator, we'll type right here SQRT 2 times 0.3 divided by 9.8. It's 0.24. อ้าว T ทำไมเราไม่เหมือนกันอ่ะเอา T ไม่ตรง the motion and the acceleration UY, yeah, 2, 3 divided by 9. It's not 0.3. No, it's not 0.3. It's actually number 3. I'm stupid. Sorry for that. This is number 3. Okay. ผมผิดเองเบอร์ครับโอเคดีนะที่มีจอนี้ไว้เช็คคำตอบตลอดเวลาเดี๋ยวถลำลึกไปไกลนะ 0.7825 second, right? Okay. ดีครับที่เปิดไว้เช็คด้วยตลอดเวลา Okay, and this we have this and I just right, the next step is that we have already finished the vertical motion, right? Now we will get back to the horizontal motion. Let's consider the x the horizontal motion. Motion. Okay, let's consider the horizontal motion, and of course, when you take a look at this, of course, the water drop or the water flow streamline is gonna move like this, right? Of course, the initial speed ux is what we have got before. Okay, it's 3 point something there, right? It's square root g. It's 3.1305 meter per second. That's the initial speed along the x-axis, and it's gonna reach. It moves right, and once it falls down and reaches the ground here, so it stops like this, right? And we get stand here, which is called the x, right? And that's what we would like to know. And yes, is there any acceleration acting on this water drop along the x-axis, okay, you would find that no acceleration, okay, along the y-axis. There's no a, no g at all. So we don't have to use these formulas for calculation, right? Because we don't have a at all. A is 0, right? It's yeah. The once you substitute a to be 0, right? Substitute a by 0, it's gonna have, you're gonna have s equal ut, right? So yes, we have s equal ut. ผมจะตามนะครับ okay, sorry for that. Yes, you have s equal to ut, and yes, what is x? S is dx, right? The distance along the x-axis, and u is the speed, right? The initial speed. There is no final speed, right? Because there is no acceleration in this motion along the y-axis, along the x-axis. V is the speed, which is 3.1305, right? T is the time along the x-axis. Okay, Tx is equal to Ty because the same water drop, right, reaches the ground or along the y-axis, and it's gonna stop also the same time once it reaches the ground here. Okay, T is there 0.7. Oh. Okay, yes, it's 0.7. It's better if I write it in on another line. It's 0.7. okay, we have just got it before right here. 7, 8, 25. Okay, and let's make the computation to that. It's right here, right? But actually, if you u is actually if you go further, we don't have to make any approximation at all because the first term is actually the time, right? It's square root g, right? It's square root g, and the second term is square root 2h whole divided by g, right? Divided by g, and you could see that you could cancel g, right? So it doesn't matter whether you use g as number 10 or 9.8 or 9.81. The x would be the same for any student. It's going to be square root 2 whole h whole only, right? H whole, which is square root 2 and number 3. Okay, square root of 6. So let's compute it. We cannot avoid. Anybody who could remember the square root of 6 would be also welcome. You don't have to bring. You don't need to bring the electronic calculator inside the midterm exam room. It's equal to 0.4495 meter. Okay, and that's it. Okay, that's correct. Okay, so we finish. We finished this example about the sheriff and a bad guy. It's cattle rustler, right? Cattle rustler. Okay, now let's move to another problem. Another problem is right here. Okay, it's not so fantasy as the previous problem, but anyway, it's acceptable, right? ผมต้องจบที่เท่าไหร่ 10 right is 9:50 right it's, 37 minutes. Okay, they have also provided the figure too, right? Okay, a large pipe with a cross-sectional area. Okay, this is the pipe, and let's say this is the second stage, the input side. Here is the output side. Okay, the water flows out, right? Get out of this pipe, but unfortunately, this pipe is special. This one has bigger cross-sectional area. Okay, the A2 here is greater than A1. Okay, this is the input side. Water get into this pipe. A large pipe with a cross-sectional area of 1 meter square. That saying 0.5 meter. Okay, they say H is 0.5 meter. All right. 0.5 meter. And narrows to, okay, the shape of this pipe is gonna reduce to 0.5. A here, A1 is 1 square meter, and A here is A2 equal 0.5 square meter, right? Yeah, you would see this, and the pressure at point 2 is at atmospheric pressure. Okay, we have ATM, PATM right here, and where it terminates to a valve at point 1. Okay, this is the valve. Let's say it's a pipe with a smaller cross-sectional area. Point 2 is subject to atmospheric pressure, PATM. We have PATM. The good thing of this problem is that they have already provided a figure. And for you, when you do the homework, please also draw the figure related to that problem. Don't write down only the text. Okay. ทำกันบ้านมานะครับโปรดอย่าเขียนมาแต่ตัวหนังสือนะครับให้เขาเรียกว่าอะไรวาดรูปมาด้วยนะครับที่ผมบอกให้วาดรูปนะครับโปรดวาดรูปมาด้วย alright YouTube มีอยู่คนเดียวนะครับตอนนี้2 คนอันนี้หายแล้ว OBS okay yes the valve is open wide, right, and water allowed to flow freely. Find the speed of the water leaving the pipe. Okay, yeah, we need to find V1 at this location. P0 is also here. Okay, when they don't provide any pressure of the air that decrease, okay, we would assume that the pressure at both sides are the same, okay, and they have already provided there here. P0 is at this side. P0 is also allocated to this side, so it means the pressure are the same. The pressures are the same for both ends. Okay, so now let's open a new empty page. Okay, let's summarize this at the first location. At the first location, we have our P1. Oh, sorry, P is P number 2. First. A second location actually. Second. Okay, P2. P2 is P0 or PATM, right? The atmospheric pressure. And Yeah, the height here, of course, it's higher than the first location. So h, oh no, we would say it's y, right? Y2 is h, okay, which is 0.5 meter, right? And V2 is the speed here, and I don't know, they don't also provide the information. They don't talk about they didn't provide the speed of the water at the input side or so. Any idea from you? มีใครทราบไหมครับ? We would leave it as unknown quantity. Okay, we don't know that. Anyway, at the first location, P1, right? P1 is, of course, the same thing, P0 and equal to P ATM, right? And Y1 here is the reference side, right? So reference location is going to be 0 meter, right? And V1 is the output speed, which is also unknown. Sorry for that. Okay, we don't know two variables, right? There are two unknown variables, V2 and V1, right? And yes, let's substitute all these 3 or 6 values into the Bentley equation. You say P1, right? Plus rho G Y1 plus 1/2 rho V1 square equals P2 plus rho G Y2 plus 1/2 rho Y V2 square. Okay. Yes, P1 is P0, so it's going to be the same, right? So we can cancel P1 and P2, right? Because both are the same here, the same value, so it's going to be both are going to appear from the Bentley equation. And what else? Of course, you know that here Y1, right? Y1 is 0, right? Because Y1 is 0, we don't have to pay attention to this at all. 0, 2, right? And what else? We don't know V1, we don't know V2 too, right? And Y2 is H. Okay, so we could divide the whole equation by rho right now. Okay, we can cancel the rho term from this one. We get 1/2 V1 square plus G Y2, which is H actually, which is H, and plus 1/2 V2 square. All right. Yeah. We laugh at this expression. We don't know both. They want to know the output speed here, V1, right? But we don't know either V1 or V2. Both V1 and V2 are unknown. So that's the result given by Bentley's equation. Okay, if you multiply the whole equation by 2, you're gonna have V1 square plus equals, right, 2GH plus V2 square, right? We keep it as the first equation from Bentley. Okay, that's the result given by Bentley. Okay, and what else could we do? Nothing more, right? So we arrive at a difficult situation because we don't, we have two unknown quantities, V1 and V2. But if you get back to the continuity equation, what is that? Continuity equation says continuity equation. It says that the flow rate, right, the volume change per time equals A1 Y1, right, equal A2 Y2, right? So what do you think? A1 Y1, A2 Y2. Oh, no, I'm stupid. A1 V1, right? A1 V1 is not Y1. A1 V1, A2 V2, right? And yeah, oh, 2 already appears. Okay, yes. We want to know V2, okay, from this expression. So we have to get rid of V1, okay, from this expression. And yes, we get rid of, remove, we have to substitute V1 into the expression only, okay, in terms of V2. Then we solve this equation. For V2, we will get the result, okay. Okay, from this equation, the continuity equation, you can get the relationship in terms of V1, right? V1 could be written as A2 divided by A1 and V2 right here, right? So that's the second equation. Now let's substitute. Equation number 2 into equation number 1, right? You're gonna have you're gonna get where is that? It's A2 by A1 square V2 square on the left, and on the right it's gonna be 2GH plus V2 square. And of course, we have to solve this equation for V2. We move V2 to the left-hand side, right? Once you move the V2 to the left-hand side, you're gonna have you're gonna get A2 by A1 square and minus 1, right? And here is V2 square, and you have 2GH on the right-hand side. All right, now we have to do, oh, I'm sorry for that balloon. Okay, number 1, 2. Here. Okay, we need to move the coefficient here to the right-hand side. Okay, so V2 will be 2GH divided by, I don't know, it's A2 divided by A1 and square minus 1, right? And because this is the V2 square, if you want to find V2 only without the power of 2, you have to take the square root on both sides, and you get the square root right here. Okay, and let's substitute that. you have here to 9.8 and h, the height, what they say is 0.5, right? What they say is h here 0.5 meter, and yes, we leave the number 0.5 right here. And the cross-sectional area, okay, cross-sectional area is A2 is 0.5. Wait, my God. Wait, my God. Let me make it small. Okay. Is that all right? Yeah, it should be here. 1 minus, right? 1 minus. Yes. 2gh 1 minus a1 by a2 but we have a2. A2 is 0.5. What they have there is a1 0.5. Narrows to 0.5. Sorry for that, I'm stupid. A2 is the cross-sectional area on the bigger side. The bigger side, I should not say it's A2, it's A1. Here A1. Okay. All right. นะครับใส่อินเด็กซ์พลาดก็งงตัวเองครับโอเคมา 0.5 and then you have A2 which is 1, right? 1 divided by 0.5, right? And you get a square here minus 1, right? You put it into the calculator. Okay, let's say we have calculator right here is square root of 9.8 divided by 1 by it's actually 2, right? It's 2 square. Okay, 2 square. Square root of 9.8 and 9.8 is 2 square minus 1. Yeah, it's 1.807 1.8074 meter per second. Is that all right? Is that correct? If we compare to the actual answer in the slide. Oh, no. It's incorrect. Oh, right. Huh? 9. 2 and 5. H is not 0.5. H, why? The height. Let's say 5 meter. I'm stupid. This is not 0.5. Blur that up. This is 5. And yes, you have to multiply the whole thing here by times 10, right? Times 10. Square root 10 and it's 1 by 4. 1 by 4, 4 minus 1, 3 and 4, right? Why? 2GH, right? 2 times 9.8 and 5. Yeah, it's 9.8 times 10. And okay, let's do the complete computation. It's right here. We have 1 part by 0.5. It's the same thing. What happened? ทำไมได้อย่างเงี้ยทำไมได้ไม่ตรง 2GH, H is 5 is 9 เขาผิดหรือเปล่าในสไลด์นะครับในสไลด์อาจจะผิด the square root of 98 by 1 minus 0.5 and then square. Yeah, that's correct. เดี๋ยวนะครับทำไมถึงเป็นเช่นนั้นเขาผิดหรือเปล่า Rho GH. Where is Rho GH? Rho GH should stay. It's not correct here. Where is that? Okay, answer the number 2. H remains as the second term. V1 is 1 here. Yeah, 2 is Rho GH, right? You move it. Oh, I'm stupid. This is V2, okay, but we don't want to find V2. Okay, yeah, I'm stupid. Okay, V2 is already correct, which is 5. Stupid. Okay, 5.7.155. But what they want to know is V1. So we get back to this equation, okay, to the second equation. Substitute again. Substitute V2 into equation number 2, okay. V2 into equation number 2. Yes, we're gonna have that, and V1 will be A2 by A1, right? A2 by A1. A2 is 1 by 0.5, okay, and times this value 5.7155, where 2 times of that, we're gonna get okay, 2 times this one is 11, right? It's the same thing right now. We get no, it's 11, right? 11.431, okay, and meter per second, okay, and that's it for this problem. Sorry, I get confused. This is not the output side V2, okay. V2 is the input side. We want to find V1. Okay, now we arrive at the last problem to this chapter. Wait, let me clear something about my throat. Okay, we arrive at the problem about the house, right? เดี๋ยวผมขออนุญาตแคปเจอร์หน้าจอก่อนแล้วกันเพื่อว่าเดี๋ยวมันลืมนะครับ all right is that today เขาส่งลิงก์มาการประชุมนะครับตายแล้ว installation yes เดี๋ยวผมขอเดี๋ยว capture ของใช้สิทธิ์นิดนึงครับโอเคthis is for Chinese right okay the line for you hereที่สุดด้วยเนาะที่สุดตรงนี้M604 shortage yes it's only single person ใช้สิทธิ์นะครับเองthis one and oh sorry installer and we gonna need the alright we gonna need this the screen capture for M604 right I hope everyone yes done that info okay yes now moment let me get out of the Zoom right Zoom here and